Hello everybody, I hope you had a nice little 3-day weekend. Today what I'm going to do is just make a quick video. I recommend watching this before you do the little quiz. The quiz will be 4 questions, but I just want to review a couple of things before you do that. If you don't need to watch the video, if you're comfortable with everything, then that's fine. This is really just optional for extra help. So what I've got here is I've got a right triangle with one of the angles as 35, and here's the hypotenuse, which is going to be 7. Now what I want to do is find the other 2 sides. So as a reminder, we've got SOHCAHTOA. Remember, this means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So what we're given here is the hypotenuse. So let's say we want to find this side over here, and let's label that AB. So let's say we want to find AB. Well, to do that, AB is across from the 35, or opposite of the 35, and the 7 is the hypotenuse. So the one that has opposite and hypotenuse is sine. So that means we're going to take and do sine of 35 degrees equal to the opposite, so AB, over the hypotenuse, which is 7. As a reminder, you guys will need a calculator for this stuff. So what you do first, depending on the calculator you have, you'll do one of 2 things. You'll either type 35 and then the sine button and then equals, or you'll type sine and then 35 and then equals. And that should come out, and then you'll multiply by 7. Keep in mind, guys, we are not rounding along the way. We just want to round at the end. So it should be approximately, and remember that squiggly equals means approximately, equal to, and I've got 4.02 here. Okay. So now let's say this one's C. Well, we need to find BC then. So to find BC, that's the adjacent to this 35. And this is, again, the hypotenuse. So adjacent and hypotenuse is cosine. So to find BC, we're going to have cosine of 35 degrees equals the adjacent, which is BC, over the hypotenuse, which is 7. So if you do that in your calculator, you'll do the cosine of 35 first, multiply by 7, and this should give you that BC is approximately equal to 5.73. So now we've solved for those other 2 parts of the triangle here. Okay? The next thing we're going to do is an example where we're using the inverses. So I'm going to go ahead and flip this over here. So let's say I give you a triangle. Here is a right angle. Let's say this is 7. Let's say this one is 5. Let's say this is A, B, and C. And we want to find, so we want to find the angles here. So find the measure of angle A and the measure of angle C. So we'll just go in order of the alphabet here, and I'll write our little SOHCAHTOA again. All right, so if we're trying to find A, so the measure of angle A, to do that, if we look at A, this side is the opposite, and this is the hypotenuse. So that's going to be sine. So we're going to have sine of angle A, sine of the measure of angle A is equal to the opposite over the adjacent, or I'm sorry, the hypotenuse. So opposite over the hypotenuse. So to do this one on your calculator, you'll do 5 divided by 7 first. Then you'll do the inverse sine button. So the inverse sine, you're probably going to have to hit either shift or second or alpha, depending on the calculator you have. They're all a little bit different. So if you do that, inverse sine, five sevenths. I get the measure of angle A is approximately equal to 45.58 degrees. So there's that one. And then to do C, we're going to again use this 5 and this 7. In relation to this angle C, though, this 5 is adjacent, the 7 is the hypotenuse. So to find the measure of angle C, we're going to have the cosine of the measure of angle C equals the adjacent, which is 5, the hypotenuse, which is 7. Remember, you always are going to do, for the inverses at least, you'll always do the fraction of the sides first, and then you'll do the inverse. So this one's going to be the inverse cosine. And I get that the measure of angle C is approximately 44.42. Okay? Remember, guys, do not use the rounded values. Yes, this comes out that if you add these together, you're going to get 90, which is what we want. But the issue is if you start rounding things and you round a little bit too far away from the decimal, then you can have issues. And if you use that in your answer, so like, let's say we started with this and we just subtracted, well, maybe this one would have been, when it came out rounded, a little bit off. So just make sure to actually do the math on both of these when you're rounding. And then same thing for the sides. So like, let's say if you do get a problem and the sides are like over here, okay, this is 4.02. This is from the first problem. Don't go back and like do Pythagorean theorem with 4.02. That's going to give you a lot of issues. So just recalculate, start over, and then get this 5.73. Okay? Hope you guys have a great day, and I look forward to talking to you guys soon. Have a good one.